Hey everyone, we all know that Microsoft Azure is a growing collection of cloud-based computing services made available to businesses, developers, government agencies, and anybody else who wants to create an app or operate a website without having to set up and maintain hardware or server software. So considering this versatility and popularity of Azure, Simplilearn has brought you a fully fledged Azure tutorial for beginners video. In this video, I'll take you around essential Azure functionalities and services and their in-depth concepts. So without doing any further ado, let's start with the video. But before diving deep into its concepts, we'll first take you through the basics, starting with understanding what is Azure, how it works, and what services it offers along with their functionality. Following that, we'll take you through the Azure tutorial for beginners, where you will learn about Azure's various concepts like its services discussed in detail, along with a proper demonstration on the Microsoft Azure console. Then we'll take you through Azure's other features provided to us, like Azure Active Directory, Azure Machine Learning, Azure Data Factory, Azure Virtual Network tutorial, and Azure DevOps tutorial, with in-depth demos for better understanding. Then we'll have a crisp comparison between AWS, Azure, and GCP. Then we'll look into some popular Azure certifications, eligibility criteria, and required skills. In the end, we'll take you through the process of how to become a cloud engineer. By the end of this video, I can assure you that all your GCP related concepts will have been cleared. I have an experienced Azure specialist Rahul with me for this training. Together, we'll walk you through the different crucial Azure keynotes. So let's start with an exciting video on Azure tutorial for beginners. Before we begin, make sure to subscribe to our YouTube channel and hit the bell icon to never miss any updates from Simplilearn.
What is Azure? What's the big cloud service provider all about? So, Azure is a cloud computing platform provided by Microsoft. Now, it's basically an online portal through which you can access and manage resources and services. Now, resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched on February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure services. Now, Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have ExpressRoute. Now, with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have virtual network. Now with virtual network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now, this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored.
Customers who subscribe to Azure get access to all of the services available through the Azure interface. These services allow subscribers to create cloud-based resources such as virtual machines and databases. Azure comes with 5 different customer support solutions from Microsoft: Basic, Developer, Standard, Professional Direct, and Premier. The scope and cost of these customer assistance programs vary. All Azure accounts get basic assistance for free. However, Microsoft charges a premium for the other support options. Developer support is $29 per month, $100 per month for standard assistance, and $1,000 per month for professional direct support. Microsoft does not provide pricing information for Premier support. Now that we have covered the basics of Microsoft Azure, let's dive down and explore the services offered by Azure. Well, there are multiple services offered by Azure, like machine learning, analytics, containers, compute, databases, developer tools, DevOps, hybrid, and multi-cloud, identity, integration, Internet of Things, management, media, migration, mobile, networking, security, storage, web, and virtual desktop. But among these, we will be discussing only a few which are widely used by organizations and individuals around the world. and we will be vividly discussing these features in depth. And these services are compute, containers, databases, identity, security, networking, and storage. Now let's start with the first one, that is compute. Azure Compute is a service that allows you to run cloud-based applications on demand. Disk, CPUs, memory, networking, and operating systems are among the computing resources it supplies, and the resources are on demand and can be accessed in minutes or even seconds. You only pay for what you use and for how long you use it. Azure offers a variety of computing solutions for development and testing, application deployment, and data center expansion. Linux Windows Server, SQL Server, Oracle, IBM, and SAP are all supported by the service. The following are some of the most well-known services: Azure Virtual Machines, Virtual Machine Scale Sets, Azure Container Instances, Azure App Service, and Azure Functions, or also serverless computing. Now let's discuss each of this one by one. First is Azure Virtual Machines. Virtual machines are software-based computer simulations. A virtual processor, memory, storage, and networking resources are among the resources available. Virtual machines, or VMs, run on operating system and allow you to install and run software much like a regular computer. You can use and operate the virtual machine as if you were sitting in front of it by utilizing a remote desktop client. Azure Virtual Machines allow you to construct and operate virtual machines in the cloud. Infrastructure as a service is provided through virtual machines, and they can be used in a variety of ways. Virtual machines are an excellent solution when you need complete control over an operating system and its surroundings. All of the software running on the VM can be customized just as on a real machine. Also, when you're running custom software or hosting arrangements, this capability comes in handy. Now coming on to the next one, that is virtual machine scale sets. Scale sets are an Azure compute resource that may be used to deploy and manage a group of identical virtual machines. Virtual machine scale sets are meant to provide real autoscale when all VMs are set up the same. Virtual machines do not need to be pre-provisioned. As a result, developing large-scale services for big computing, big data, and containerized workloads is easy. More VM instances can be added as demand grows. VM instances can be withdrawn when demand decreases. The procedure might be human, automated, or a hybrid of the two. Now moving on to the next one, that is Azure Container Instances. Container instances are Azure compute resources for managing and deploying containers. Containers are virtualized application environments that are lightweight. They're built to be dynamically formed, scaled, and stored. On a single host machine, you can run many instances of a containerized application. Then comes Azure App Services. You can create, deploy, and scale enterprise-grade web, mobile, and API apps on any platform with Azure App Services, while employing a fully managed platform to handle infrastructure maintenance. You can meet stringent performance, scalability, security, and compliance requirements. A platform as a service solution is App Service. And following that, we have Azure Functions. When you simply care about the code that runs your service and not the underlying platform or infrastructure, functions are great. They are frequently used when you need to respond to an event, typically via REST request, a timer, or a message from another Azure service, and the job can be accomplished rapidly in seconds or less. Now that we have completed all the services offered by compute, let's proceed to the next one, that is containers. Containers are a type of virtualization system. You can run several containers on a single physical or virtual host, in the same way that you can run numerous virtual machines on a single physical host. Unlike virtual machines, you don't have control over a container's operating system. Containers are lightweight and designed to be built, scaled out, and stopped dynamically, whereas virtual machines appear to be instances of an operating system that you can connect to and administer. Containers are built to help you to react to changes on the go. Containers allow you to swiftly resume in the event of a crash of hardware failure. Docker is one of the most popular container engines, and Azure supports it. Containers offer these particular services: container instances, Azure Container Services, and Container Registry. Container instances are the quickest and easiest method to operate a container in the Azure without needing to manage virtual machines or use any extra services. It's a PaaS service that lets you upload your containers and have them run for you. Moving on to the next one are Azure Container Services. Azure Container Services or Azure Kubernetes Services allows users to manage, deploy, and control operations of a Kubernetes container. Orchestration is a term used to describe the process of automating, managing, and interacting with a large number of containers. Azure Kubernetes Service is a comprehensive container orchestration service for distributed architectures and high volumes of containers. And then comes Container Registry. A container registry is used to ease container development by easing storage and management of container images. Now that we have covered containers and the services offered, let's move on to the next Azure service, that is databases. Azure Database is a fully managed platform as a service database engine that automates the majority of database management tasks, such as updating, patching, backups, and monitoring. Microsoft has released a managed instance aimed at on-premises clients. So if we have any SQL databases on-premises that we want to migrate to Azure without any complex configuration or ambiguity, we can use managed instances. The most prominent services under database service are Azure Cosmos DB, Azure SQL Database, and Azure PostgreSQL. Now coming to the Azure Cosmos DB. Azure Cosmos DB is a multi-model globally distributed database service. You may increase throughput and storage across any number of Azure locations around the world in an elastic and independent manner. You can use any way of several common APIs to get single-digit millisecond data access. Throughput, latency, availability, and consistency assurances are all covered by Azure Cosmos DB's service level agreements. Now, Azure Cosmos DB enables schema-less data, allowing you to create extremely responsive and always-on apps that can handle constantly changing data. This functionality can be used to store data that has been updated and maintained by users all around the world. So next comes Azure SQL Database. Azure SQL Database is a relational database based on the Microsoft SQL Server database engine's most recent stable version. SQL Database is a fast, dependable, well-managed, and secure database. You may use it to create data-driven applications and websites in your preferred programming language without having to worry about infrastructure. What is Azure Active Directory? But before getting into the definition of Azure AD, let's have a real-life example of Azure AD to understand it in a better way. There are a lot of pre-created applications that you can offer user access to using Azure AD. So Netflix is one of them. So here's the scenario. You want to share a Netflix account with a dozen people from your organization. Giving your Netflix username and password to everyone isn't safe. So how do you give them access? Here enters Azure AD. The Netflix application is available in the Azure AD gallery and can be added to your Azure AD tenant. This adds the application to your tenancy and allows you to save your Netflix credentials in the secured credential store so that users can be assigned to it. The only people who have access are the ones you give it to, unless they have their own account. You're essentially building a company-wide password vault, then assigning people to the systems. They require access to so they can log in without knowing the username and password for those systems. All they need is the Azure AD account or password, and Azure AD will handle the rest. So saying in technical terms, Azure Active Directory is a cloud-based identity and access management service from Microsoft that allows your employees to sign in and access resources such as Microsoft 365, the Azure portal, and thousands of other SaaS apps, and internal resources such as apps on your company's intranet and network, as well as any cloud apps built by a company. Azure AD is required for sign-in and identity protection in Microsoft Online Business Services, such as Microsoft 365 and Azure. If you sign up for any Microsoft Online Business, you will be given access to Azure AD, which includes all of the free services. But what makes Azure AD so different from Windows AD that it has become more popular among people from technical firms? What is Windows AD? Active Directory saves information about network objects and make it easier for administrator and users to find and use their information. It organizes directory information logically and hierarchically using a structured data store. But its supreme drawback is its layers. So let's have a look at its layers and its functioning. First is ADDS, Windows Active Directory Domain Services. Active Directory Domain Services is an example of a directory service that provides mechanisms for storing directory data and making it available to network users and administrators. Second is ADFS, Active Directory Federation Services. Federated identity and access management is made possible by Active Directory Federation Service, which securely shares digital identity and entitlements right across security and corporate boundaries to provide customers, partners, and suppliers with a streamlined user experience while accessing an organization's web-based applications. ADFS extends the ability to employ single sign-on capability accessible within a single security or enterprise boundary to internet-facing apps. Third is ADRMS, Active Directory Right Management Services. Microsoft's Active Directory Rights Management Services safeguards sensitive documents and emails, unlike traditional security methods like firewalls and ACLs. ADRMS encryption and protection remain constant regardless of where a file goes or how it is transferred. But Azure Active Directory actually combines these layers and make the whole process more easier and hassle-free. Azure AD combines these layers into two layers, WAAD, Windows Active Azure Directory, and Windows Azure Access Control Service. Windows Active Azure Directory combines all the problems revolving around identification management. And Windows Azure Access Control Service takes care of federating all the services of an organization. So let's have an example. When an employee joins the premises of an organization, the administrator guides them towards signing to particular services they use and then give access to it. And the employees can access these services through their credentials like username and password. Now that we know what is Azure Active Directory and how it functions different from ADDS, let's have a look at the service audience of Azure Active Directory. Azure AD is majorly intended to IT admins, app developers, and online subscribers. For IT admins, you can use Azure AD as an IT administrator to limit access to your apps and app resources based on your business needs. When accessing critical organizational resources, for example, you can utilize Azure AD to enforce multi-factor authentication. Finally, Azure Active Directory provides you with strong features to help you protect users' identities and credentials while also meeting your access governance requirements. As an app developer, you may utilize Azure AD to add single sign-on to your app using a standard-based method, allowing it to function with the user's existing credentials. Also, Azure AD has APIs that may be used to create customized app experiences based on existing organizational data. For online subscribers, you're already using Azure AD as a subscriber. Each tenant of Microsoft 365, Office 365, Azure, and Dynamics CRM Online is an Azure AD tenant by default. You may begin managing access to your connected clouds apps right away. So now that we know the basic concept of Azure AD, let's have a quick demo of it. So the first thing we need to do is log in our Azure ID account and then go to Azure Active Directory sector. Here you will see add option where you can add a user, group, enterprise application, app registration according to your choice. And below that, you can search for any tenant like for user or for any group. So right now it doesn't belong to any group or there is no user with this name. Here you will get basic information like their name, what is their ID, what is the license, which groups they belong, and what all devices they use. You can also have an access to their password as well.
So without doing any further delay, let's start with the video. So what is Azure Machine Learning? Azure Machine Learning is a cloud solution that helps you speed up and manage your machine learning projects. It can be used by machine learning specialists, data scientists, and engineers in their daily workflows. Models are trained and deployed, and MLOps are managed. You can use an open source platform like PyTorch, TensorFlow, or scikit-learn to build a model, or use one created in Azure Machine Learning. Model monitoring, retraining, and redeployment are all made easier using these tools. But this brings us to a question that who exactly machine learning is for? So individuals and teams deploying MLOps inside their company can use Azure Machine Learning to move machine learning models into production in a safe and auditable environment. Data scientists and machine learning experts will find tools to help them speed up and automate their daily tasks. Tools for embedding models into applications or services will be available to application developers. Platform developers will find a strong set of tools for constructing advanced ML technology underpinned by resilient Azure Resource Manager APIs. Now that we know the basics of Azure ML, let's have a look at its infrastructure readiness and security. So Azure Machine Learning is an Azure cloud platform that adds security to machine learning projects. So integrations for security include the following: network security groups in Azure Virtual Networks. Azure Key Vault is a vault where you may store security secrets like storage, account, access details, and set up an Azure Container Registry behind a VNet. So now let's dive down deep and explore its project workflow. Models are usually created as a part of project with a specific goal and objective. Multiple people are usually involved in these projects. Iterative development is used while experimenting with data, algorithms, and models. Now coming to the project life cycle, while the project lifespan will differ depending on the project, it will typically look like this. A workspace organizes a project and facilitates collaboration among multiple users who are all working toward the same goal. Users in a workspace may easily share the result of their experiments through the studio user interface, or they can use versioned assets for jobs like environments and storage references. So users' work can be automated in a machine learning pipeline and activated on a timetable or HTTP's request when a project is ready for operation. Therefore, models can be deployed to the manage inferencing solution in real time or batch, abstracting away the infrastructure management that is traditionally necessary for model deployment. Now let's proceed further and understand the concept of MLOps, that is DevOps for machine learning. MLOps or DevOps for machine learning is a process for generating models for production use. If not reproducible, the lifetime of a model from training to deployment must be auditable. MLOps or machine learning operations is based on DevOps principles and methods to improve workflow efficiency. Continuous integration, delivery, and deployment, for example. These ideas are applied to the machine learning process by MLOps with the purpose of experimentation and model deployment can be done more quickly, and quality assurance and end-to-end lineage tracking are more efficient ways to put models into production. Now, let's explore what is Azure ML Studio. So, Azure Machine Learning Studio is an online service that includes low-code and no-code alternatives for project development and asset management in Azure Machine Learning. Basically, it is a workspace where you can create, build, train the machine learning models. For an inclusive data science platform, the studio integrates no-code and code-first experience. So now that we have covered all the important concepts of Azure Machine Learning, let's have a demo for a better understanding of how machine learning is used in Azure. So let's start with a demo. First, you need to browse the link studio.azureml.net, and here you need to log in with your Azure account. So once you have logged in, you will be led to a new window. This is the new window. Here you can see a few options. So let's start and see one by one what these options are. So the first one is projects. Basically, this gives you a list of all the experiments that you have already worked on. So here you can see we haven't worked on any experiment yet. Then comes experiment. Experiments are all the programs and codes that you have worked on to create it or deploy a model that you have just created for an experiment. So as I said, we haven't created any experiment yet, so the list is null over here. When you click on samples, you can see a few sample experiments provided to you by Azure portal by default. And following that, we have web services. So we all know, since Azure is a cloud computing platform, so all the data gathered from our experiments needs to be uploaded to the cloud. So web services gives you a list of all the experiments that you have in the cloud, so you can access them from anywhere. So when you create an experiment and work on it, when you add it to the cloud, that data is stored here. So then comes data sets. It gives you all the data sets you have in your Azure portal. When you click on the samples option, again you can see all the data sets provided to you by default in your Azure portal. Then comes train models. So while working on an experiment, you will come across a point where you need to train your model. So basically, this gives you a list of all the models that you have trained in your experiments or Azure programs. And in the last comes settings. Any changes that you want to make to your workspace is done under settings. Here you can see this is your workspace name, workspace description, which is by default, and all the details is provided here only. So whatever changes you want to make to your workspace, you will be doing this over here. So now let's start with a demo. So down below you can see the add or new option here. So click on it, and then you can see there are a few templates provided to you by Azure itself. So we'll click on blank experiment. Once you click on the blank experiments, you'll be guided to a new experiment window. So this is the new window, and this window is divided into 3 parts. These are the components where you will plan your model. This is the canvas to design your model, and then the properties of the model. In the components section, you can see samples already present there. So you can select any one of them according to your requirement. So here when I'm typing samples, I'll work on airport codes datasets. So I just need to drag this option over here. But before starting with our experiment, let's change the name. So here I'm changing it to airport codes demo model. So now you can see the name of the experiment is changed. Now when you click on it and select visualize, just a second, you can see the number of rows and columns provided to it, the data which is required for its dataset to be created and for its model to be created. So the 4 columns are airport ID, city, state and name. Now we will move towards the part where we define the field we need to make our predictions for. So type columns in the search bar. Under manipulation section, you can see there are multiple options provided to you. So here we will select columns and data sets, as we are working on data sets. Now connect your data set with this option. So you can see a red alert over here. So when you click on it, you can see it is asking for values in your dataset. So to add values, click on the launch column selector under properties section. So once you click on it, here you need to select all the options needed for your required values. So for my experiment model, I need all these data sets. So I'll add all of these and then click on the save option. So let me just add these. So now I have saved all the values I need in my data set. So now you can see the alert is gone. So now we have the data sets that we want to work on. So let's look for an appropriate algorithm for it. So while looking into the classification algorithm, we know that so here you can see it under classification model, we have these options. So we know that our target value is divided into 2 classifications. So the algorithm we will be using is a 2 class. So we will be using 2 class booster decision tree because it calculates the accuracy for every node, and once the calculated accuracy is more than our required accuracy, then only it moves to the next node. So basically this gives you a prediction value close to the accurate value of the model. So we will just drag this option over here. So now the next step we have is to train our model. So we just need to type train over here and select train model option. Yeah. So just drag it to the canvas. Now connect the two booster decision tree to the train model. Now you can again see the red alert for required data, as it doesn't have any data to work on. So our next step is to split the data. So we'll type split and drag the split data option on our canvas. As you can see, this is also saying it needs an input port data set. So we'll connect our data set with it so that it is provided with the data. So when you click on it, you can see it is asking for a split percentage. So you split the data into training and testing, where 80% goes to training and 20% to testing. So we will mention 0.08 over here, and so now we will just connect the 80% data to the train model. As we said, the 80% goes for training. But you can still see the alert in the train model because it is not aware of the column it needs to train on. So we will click on launch column selector. Now you just need to select all the columns you need to work on. So I'm selecting the airport ID number. Now you can see once I save it that the alert is gone. Now our next step is to find the score of our model. So let's type score in our search bar and drag the score model over here. Let me just reduce the size of the canvas. Yeah. So we will just connect our train model to the score model. So again you will see the red alert as it doesn't know the data it needs to test on. So for that we will connect the remaining testing data in the split data option to the score model. Now you can see the alert option is gone. Now coming to the final step, that is evaluation of the model. So let's type evaluation, and here you can see the evaluate model option. We just need to drag it to the canvas. Yeah. So let's connect it with our score model. Now your model for the airport code dataset is complete. So this is the whole model. Now you need to save the model and then click on run option. So here I've saved it, and you can see it's running. You can see the model running and going through every node. As you can see the green mark as it's verifying through every node. So once it's done, click on evaluate model and then click on visualize. Now you can see the accuracy is 98. Here you can see the accuracy is 98, which is almost the prediction value. Now you can see the positive and negative labels as well. So this whole data is known as confusion matrix. Now for the values close to the positive label, it gives me the number of true predictions. That the number of data I'll provide, it shows that 72 predictions will be right and 1 will be wrong. Now let's go back and run this model over the web. So by clicking on Setup Web Service, we will click on Predictive Web Service. Now we will just connect web service input to the score model. So that once the program is uploaded to the cloud, it is directly connected to the score model and gives us the output. So now you need to save this and run. This will execute the entire model. Now all we are left with is deploying the model. Now we just need to click on deploy web service. So then you will see you will be taken to a new window. Here you can see the response page where it's showing the test option. You need to click on it. So here you can see a new window has popped up. So you just need to mention the details. Like for city I am mentioning Bangalore. For state I am mentioning Karnataka. And name of the airport is Kempagoda. International Airport. And I just need to save this data. So now down below you can see it gives me predictive values, and this is the airport ID for my mentioned details. So the accuracy of this ID will be 0.98, which is 98%, which is almost accurate to the 100%. So this was our experiment, and this is how we can use ML in Azure. Thank you.
Now let's consider a scenario. So here we have two colleagues having a conversation with each other, and they say that the data that they're generating from their applications or products is increasing exponentially. Now, considering that this data is coming from a number of different products, it'll be a bit of a task to analyze and store all of this data. So he wonders how they're going to manage that. His friend suggests that they use Azure's Data Factory. Now, what does Azure's Data Factory actually do? First, it stores data with the help of the data lake storage. Now, any kind of data can be stored in the data lake storage. Then you can analyze the data, you can transform the data with the help of pipelines, and you can publish the organized data. You can visualize the data with third-party applications like Apache Spark or Hadoop as well. Now, what exactly is Data Factory? So now let's have a look at what exactly is Data Factory. Now, Data Factory falls under the identity domain of services in the Azure catalog and is a cloud-based integration service. Basically, what it does is it works on your data, it stores your data, it orchestrates and automates the movement or transformation of data. It works heavily on the data that you store. Now, let's see how it actually works or how the flow of its processes are. Firstly, we have the input data set, which is nothing but the data that you have within your data store, the one that you need processed. Then you pass this data through a pipeline. Now, what does a pipeline do? A pipeline basically performs an operation on the data that transforms it, which could be anything from just data movement or some data transformation. Now, data transformation is possible with the help of USQL, some stored procedures, or Hive. Now, after this is done, you get an output dataset. Now, this output dataset will contain data that is in a structured form because it's already been transformed and made structured in the pipeline stage. Then it is given into linked services like Azure Data Lake, block storage, or SQL. Now, what it does is these store information that is very important when it comes to connecting to an external source. Now, this is, if you wanted an example, how in an SQL server you need to mention the source and destination of your data. Now, for example, consider an SQL server. So you need a connection string so that you can connect to an external device. You need to mention the source and the destination of your data. This is how the link services work. And finally, you need a gateway. Now, a gateway basically connects your on-premises data to the cloud. So you do need a client installed on your on-premises system so that you can connect to the Azure cloud. And finally, you have the cloud. Here what happens is your data can be analyzed or visualized with a number of different analytical softwares like Apache Spark, R, Hadoop, and so on. So all this time I've been mentioning that data lake is a very important part when it comes to Azure Data Factory's proper functioning. So now let's talk about what exactly is data lake. Now, data lake is a data storage or a file system which is highly scalable and distributed. It is located in the cloud and works with multiple analytics frameworks, which is external frameworks like Hadoop, Apache, and so on. So now let's have a look at it. So first you have your output data set, which is data from the mobile, video, web, social media, so much more. It is sent into the Azure Data Lake store, and then it is provided to external frameworks like R, Apache, and Spark so that they can be worked on. Now, there are two main concepts when it comes to data lake storage. So one of them is storage and the other one is analytics. Now, storage is of unlimited size. It can be petabytes, terabytes, gigabytes, and so much more. It stores a wide variety of data. It could be unstructured or structured data, and it can store really large files. And another concept when it comes to data lake is analytics. Now, how it works. Now, here are two examples of how analytics works when it comes to data lake. Now, when it comes to analytics, you can monitor and diagnose real-time data. For example, data that you're getting from vehicles or buildings. These can be used to optimize how they work, respond to certain events, or generate alerts in case something goes wrong. Then you can also identify fraudulent transactions on your credit card, or you can identify the geographical position of your card. Perhaps monitor how many transactions have been taking place on that card, and so on. So now we're going to have a look at how we can use the Azure Data Factory to move data from an SQL database to a blob storage on the cloud. So here's what we're going to do. So first off, to make a database, what you're going to need is software known as SSMS. So you can find it on Google. You just need to Google it, SSMS. The first link you can take here, and there you have it. So you just need to click here and download the file. So I've already downloaded the file. So basically this is used to create a database which we'll be transferring to the blob storage. So this will take about, depending on your computer speed, pretty long or little to no time. I've already downloaded it. The process is very simple. Just directly go on saying yes, yes. And finally, once the installation is done, here's what we're going to do. We should go into the dashboard of Microsoft Azure. We need to create a data warehouse. So we'll go into all resources, create resource, go to database, and select SQL data warehouse. There we have it. Now, it's very important that you remember the names of the service of everything that you're going to write here, because each of these become very important later on. So I've already set up a possible set of names. YouTube, it's free trial. The resource is already created. A blank database. The server, we need to create a new one. So we'll name it as YouTube server. YouTube admin as the server admin login. The password as alright, the location does not matter. Okay, that's done. Now here the server is done, and here we need to change how much you want the lowest, how much computation you want, how much the workload, how important your workload is. So we'll put it at the lowest since we don't require much. We'll apply. The rest is normal and create. So now we're creating an SQL data warehouse. So we'll wait. So now the deployment is done. So we'll go to the notification and go to the resource. Here, now this is done. So we'll go to the SSMS, which I've already opened here, and then go here and copy this, paste it here, SQL authentication, login, which details we have already stored here, which is admin, YouTube admin, and the password, which is also given there. Right. Go to options. We go to the database name, which is YouTube. Everything else is there. We need to change it to TCP/IP and connect. We sign in. We'll add the password. Again, we're going to sign in now. Right. So now that that's completed, you can see that this is what will pop up. So this is the name of the server we've given, as you saw earlier. You go to databases, and here you have the YouTube database that we just created. Right click this and add a new query. I already have a code for this program. It's a very simple program, so copying and pasting this. Now, if you need the code for this program, let us know in the comments below. It's very simple. What we're doing is creating a table called demo tab with first name Clark Kent and last name is Bruce Wayne, and the table that's created will have these two rows. So now we're going to execute this. And there you have it. Two rows have been affected. So now let's have a look at our table. Execute this line, and there you go. The table's here. So now that this is done, we're going back into Azure, and we need to create a storage account. So that's where the blob storage is going to happen. So we're going to storage accounts and click on add. So here it's a free trial. The resource group is YouTube. Storage account name is Simply Store. That's all. Okay. US performance is standard. General purpose can do locally, since we don't need it to be very reliable, at least for this one. Advanced is fine. View and create. That's done, and we create. Now we'll wait for the deployment to finish. And that's it. The deployment is done. So we'll go to the resource and go to blobs. So this is where the storage is happening. We need to create a blob. Simply blob, which does not exist, and okay, it has been created. Now for the next bit, we need to create the data factory now. So we go to all services, search for data factory. We press add. So here we'll free trial, use existing, which we have YouTube, East US, and create. So now we've created a new data factory. Now we'll wait while it's being deployed. So now it's created. So we'll go here, and here we click on copy data, and this opens up. We'll name it. Now description, run once now. Okay. Right, so we press next. So we need to connect to a data source. So what you need to do is select Azure SQL data warehouse. So one second, go to previous. Here we select Azure SQL data warehouse. Go here, search for source, Azure subscription, free trial, here YouTube server, and the database is YouTube. You also need to provide your username and password. I've saved it here. YouTube admin. Right. Okay, now we can select the table, which is demo tab. Next. And now for our destination. So where are we going to connect this to? We're going to Azure Blob Storage. Next, destination, Azure subscription free trial, and Simply Store. Now we need to name our name our storage path. Next, all of this can be passed on. So here's what we're doing. We're copying whatever is inside this to the Azure Blob storage. That's what's happening right now. All of that is set, and next, it's validating, and we'll wait now. It's registering connections, creating database, and in the end it's creating a pipeline. So you can monitor the pipeline from here if you feel like it. Now, here's what we're going to find. So here's the visual representation of what's happening. It's being copied into the blob storage. Now let's have a look if it's actually worked out. We go to our database, we'll go into storage accounts, simply store, go to blobs. We've created a new one, and there you have it. So based on the container that you've named there, it's created a new one here. So actually I had earlier created the name called simply blob, but as you can see here, as long as you name a container, it'll create a folder inside which you will find your particular thing that you copied. And that's it, you've copied data. Similarly, you can do a number of multiple operations on this container, on the pipeline you just created with the data factory. And that's that. And with that, we've reached the end of another video. I hope you guys found this informative and helpful. Thank you for watching and stay tuned for more.
So first of all, let's look into why is Azure Virtual Network important. So why Azure Virtual Network is required. So somewhere far away at an office, a company was struggling with few challenges. The company got a bigger projects which lead to the following challenges. That includes poor network connectivity, time-consuming process in building network topologies, could not divert network traffic to its destination on time. So these were a couple of challenges the company was facing. So the employees thought that what could be the possible solution to these challenges? And then we require the Azure Virtual Network in that case. So first of all, let's understand what is Azure Virtual Network is. An Azure VNet or a virtual network represents your network or environment to run VMS and applications in the cloud. When it is created, the services and virtual machines within the network interact securely with each over the internet. So virtual network, you can consider it as a virtual cloud, which is basically kind of a cloud space virtually assigned to the users or to the organization, which they can dedicatedly use for their purpose. So for example, if you have to create some instances or virtual machines onto the Azure cloud, and you want to connect it with the on-prem servers, for example, then you might require the virtual network in that case. Let's assume that those instances that are created in the virtual network require the range of IP addresses that you want to allocate to them, and that is something you can customize using the Azure Virtual Network. How do you want that the traffic should be routed to your instances in the virtual network, how the firewall securities should be applied? Everything the end user can control in the virtual network. So it seems like that you are working in your own data center. Ideally, you would be working onto the Azure cloud using the virtual network. Now, what are the advantages of using the Azure Virtual Network? So a couple of them are, it provides an isolated environment for your application. So as I said that it seems like that you are working in your on-prem environment. That means within your data center. But ideally it is a virtual space that is allocated to you, which is a kind of an isolated environment that is specifically designed for your task and the activities. Generally a subnet in a VNet can access the public internet by default. So we create a subnet inside the virtual network which can access the public internet. So there is a public network connectivity that is enabled in the virtual net so that a subnet which will be created in the VNet can be accessed. Traffic can be easily filtered from different resources. So you can have some control lists defined, you can have some security groups created, and how do you want to allow the traffic onto the servers or the application? That is something which you can control. It is a highly secure network and the security groups and the policies are basically implemented by the end user. So you can design how the security should be implemented. High network connectivity, so you have a higher bandwidth as compared to the normal internet connection you might be having in the data center. Compared to that, you use the Azure network only, which gives you the higher network connectivity. It builds sophisticated network topologies in a simple manner and which is easily manageable, as well as there are less troubleshooting issues that we would encounter. Now, what are the components of Azure Virtual Network? One of them is the subnets. Then you have routing. Then you have network security groups. Now, what do we mean by subnets? The subnet is one of the major or a prime important component in the virtual network. So what you have to do is, first obviously you would be creating a virtual network. Inside that you can create the subnets. Subnets, you can consider it a logical partitioning or virtual partitioning inside the virtual network. Subnet lets user segment the virtual network into one or more subnetworks. For example, let's assume that you're working in an organization, and in the organization there are different departments. For every department there should be some set of IP addresses that you want to allocate to the machines that the employees are using. Or all the departments should be isolated. That means that they should have their own network IDs and the network addresses allocated to their machines. And in that case, what you would do is you would create the subnets and the subnet IDs that would be allocated to those departments. These subnetworks can be separated logically, and each subnet consists of a server. So what you do is, when you create a subnet, you can create a server or an instance inside that subnet. And how do you want to give an access to that instance depends on criteria or the requirement. Hence, a subnet can further be divided into two parts, one as the public subnet and the other one as the private subnet. These are the naming conventions of the subnet. Then how do you want to give the internet connectivity depends on how the public subnet should be interacting with the internet. And for the private subnet, as the name suggests, that the internet is blocked. So that means it is completely isolated in the virtual network. The private instances, though, if you want that any instance created in the private subnet should have the internet connectivity or an access, you can primarily go with the NAT gateways in that case, which is a network address translation or kind of a translator which converts the private to public and vice versa. And that would actually enable the internet connectivity to your subnets. Then in the public instances, they can directly access the instance. As the name suggests, public instances, that public subnets, that means they have the direct internet connectivity. Next component is routing, and the routing is primarily a routing rules, you can say, that are applied, and those are actually applied to the routers only. So since on the cloud we cannot have a direct router access, and hence using the routing as a component, we can define some routing rules which are directly applied to the router in the infrastructure. It delivers the data by choosing a suitable path from source to destination. For each subnet, Azure Virtual Network automatically routes traffic and creates a route table. When you create a virtual network, automatically a route table is created, and that basically is required to route the traffic, and that can be used by every subnet. That doesn't mean that you only have to create a single route table in the virtual network. You can have multiple route tables also created, which can be associated with different subnets as well. Then you have the network security groups. It is kind of a firewall that protects the virtual machine by limiting the network traffic. It restricts inbound and outbound network traffic depending upon the destination IP address port and the protocol. So it is basically the network security group sits on the instances and or virtual machines, and they basically define that how the traffic should be reaching to the ports onto the virtual machine. So how do you want to open up the ports, and for which IP addresses you want to open up the ports? That is something the end user or the administrator has to specify or design. So they act as a kind of a firewall rules only that protects the virtual machines. So how to launch an instance using Azure VNet? So first of all, you have to create a virtual network. So virtual network act as a container for subnets. So first thing is that you would be creating a virtual network. Then you would be creating subnets which are considered as a subset within the virtual network. So cloud instances included in the subnet. So first VNets are created, then the subnets are created, and then you configure the properties in the security group. Have a look at this in detail. Now, with respect to the virtual network, what you need to do is you have to create a virtual network in the Azure cloud. Then you have to create subnets into each virtual network, which is kind of a subset of a virtual network. So you can create one as a public subnet, the other one as a private subnet, for example. Now you have to assign instances. So when you create an instance, you have to specify that what is the virtual network, for which virtual network you are creating an instance. Within that virtual network, you have to select that on which particular subnet the instance should be created. And then connect instance to a relevant network security group. So attach your network security group to the instances, and based on the properties or the rules that are defined in the network security group, that will be applied to the instances within the subnets. Finally, configure the properties in the network security and set the policies. As a result, you will be able to launch your instance on Azure within the virtual network. Now we will be seeing one demo that how we can create Azure Virtual Network subnets and the network security group. So just be there to watch our demo on the Azure Virtual Network. In today's session, I would be showing how you can create the virtual networks onto the Azure. And for that, you require the credentials on Microsoft Azure, and here you can see on my screen that I have already logged in into the Azure console. Now what you need to do is, in order to search virtual network, you can type and search in the dashboard, in the search bar, with respect to the virtual networks. And here you can find the virtual network and the gateways. So what you need to do is you just have to click on the virtual networks, and then it will give you the options to add the components inside the virtual networks. So let me first open up the virtual network. Right. Now, in theory, we discussed that the virtual network comprises of multiple components and subcomponents. So primarily is that first you have to create a virtual network. Then you have to assign the IPv4 CIDR block to the virtual network. And then you create the subnets inside the network, which is a subset of the virtual network. Along with that, you define the routing rules. And likewise, you create the instances inside the subnets that will be part of the virtual networks. So that's what we are going to do in this demo. So I would be adding up a new virtual network. So you can see here there are already two virtual networks that have been added. One is the demo VNet, which is by default. So when you created the Azure credentials, the demo virtual network was already created by the Azure, so that it can provide you the default settings. And then the test one has been created by me, and that's the customized one, or you can say a non-default virtual network. So I'm going to add another VNet and would define the name to it. So let's wait for the details to appear. So here you have to define the virtual network to create. Obviously we will be going with the free trial only. And then you have to create a resource group. So what is a resource group? It is primarily a collection of resources that share the same lifecycle, permissions, and the policies. So if you have a resource group created, you can use it. Otherwise, you can create a new resource group. So I already have one, that is the demo one. I would be using that. In the instance details, you have to specify the name of the virtual network. So these are certain parameters that you have to go with while defining the name. So let's say I put something like test VNet as the virtual network that I want to create, and that is, you have to select a region where you want to get that created. So these are the available regions that you can select. I would go with US East US only, and then we have to define the IP addresses also. So in the IP addresses, the CIDR blocks are allocated to the virtual networks, and that becomes a fixed IP address for that VNet. So what you can do is you can specify a range of IP addresses. Now whenever we talk about a virtual network and the IP addresses, we primarily focus on the private IPs only. So this is the private IP that we are actually talking about. So I can reserve some IP address CIDR for our VNet, and that is the range of 40.0.0.0/16 I'm going to reserve. So now we'll create one subnet, and we'll name that subnet. So as we discussed, that subnets are the subcomponents of the VNet. So here you can see we have already created one subnet with the name public subnet. So likewise, we can add another subnet also, and let's name it to something like demo subnet, right? And the subnet should have the IP address range, and that IP address range should be part of the VNet only. In V18, so same subnet address range you would be defining in the subnet as well. So that will be 40.0.1. Or we can select 2.0/24. The rest of the things would be default. We are not attaching any route table as of now. So just click on OK. And here you can see that the subnet is created. Now once the subnet is created, now we are going to create a virtual machine inside that subnet. And for that, we'll go to the search bar, and here we'll type virtual machines. Now we'll create a virtual machine in the same VNet, that is the test VNet, and inside the demo subnet, so that our virtual machine gets the private IP address from the subnet that has been created in the VNet itself. So what you need to do is you have to open up the virtual machines, click on add, and here you should add a new virtual machine. So you should select the name of the virtual machine and the network details, where we would be defining the VNet as well as the subnet where the virtual machine should be created. So in the subscription, we'll go with the free tier, and in the resource group, we'll go with the demo that has already been created. We'll put a virtual machine name, something like test VM, and the rest of the things will be default. So we'll quickly skip the disk check also. Now in the networking, we would be selecting the test VNet as our virtual network, and in the subnet we would be selecting the demo subnet. So that is the recently one added in the test VNet, and we want that our virtual machine should be part of that subnet only. Now obviously, since we are creating a virtual machine, so it should be part of, it should have the public IP also assigned, since from the public network we need to access those virtual machines. So we'll keep it enabled, right? And the next would be the default settings that we are going to proceed with. So let's review all the configurations and then create your virtual machine. So here you can see that our virtual machine has been created, validation has been passed, and it takes a couple of minutes to get that updated. So let's wait for a few more minutes so that our virtual machine is ready. And primarily what we want to look into is that our virtual machine is created in a correct VNet, and it gets the private IP address from the subnet that has been part of the VNet which has been defined in the creation of a virtual machine. So let's wait for a couple of more minutes, and we'll look into the status of the VNet. Now you can see here our test virtual machine has been created. Now what we wanted to look into is that our virtual machine is created in a correct subnet or not, and that is something which we can validate by checking the private IP address. So it got the private IP from the range of the IP address that we have specified in the subnet. Now in order to access this particular virtual machine, you have to use the public IP, since we have to access it from the internet. So from the private IP, this virtual machine will not be accessible. So that's the reason that when we created a virtual machine, we allocated the public IP address also for this instance. So that is with respect to the virtual network and the demonstration on it, and how we can create a VNet and the subcomponents of the VNet, how they are associated or interlinked with each other, and that actually creates a kind of an isolated environment on the public cloud, which gives you the understanding that you can work into just like an on-prem environment.
First, we will understand what is Azure DevOps, followed by features of Azure DevOps. Then we will dive into and explore Azure DevOps Services, followed by Azure DevOps Server, and then we will look into the Azure DevOps Services and Azure DevOps Server differences. And at last, we will explore Azure DevOps Labs with proper demonstration. So let's get started. So what is Azure DevOps? Azure DevOps enables teams to organize work, collaborate on code development, and build and deploy applications using developer services. Azure DevOps is a culture and set of protocols that brings together developers, project managers, and contributors to collaborate on software development. It enables businesses to create and enhance products more quickly than they could with traditional software development methods. You can use Azure DevOps services in the cloud or Azure DevOps Server on premises. Azure DevOps has built-in functionality that you may access via a web browser or an IDE client. Depending on your business needs, you can use one or more of the following standalone services. Azure Repos. Azure DevOps are built-in functionality. So for source management of your code, Azure Repos offer Git repositories or Team Foundation version control. Azure Pipelines. Build and release services provided by Azure Pipelines to assist continuous integration and delivery of your applications. Azure Boards. Using Kanban and Scrum methodologies, Azure Boards provides a set of agile tools for planning and tracking work, code bugs, and issues. Azure Test Plans. Manual and exploratory testing and continuous testing are among the options available in Azure Test Plans for testing your applications. And at last, Azure Artifacts. This allows teams to share packages from public and private sources, including Maven, NPM, NuGet, and more, and incorporate package sharing into their pipelines. So this brings us to the features of DevOps. First we have is dashboard control. You can rapidly navigate to different regions of the project, build and manage dashboards, and set dashboard widgets using the DevOps dashboard functionality. Then we have improved source control. Git and Team Foundation version control, a centralized client-server system, which are two prominent methods of source control supported by Azure DevOps solution. To observe change history, you can add and manage Azure Git tags, reviews, downloads, and modify files. Following that, we have plan and track your work. You can utilize Azure DevOps systems to track features, requirements, user stories, tasks, issues, and more using a variety of work items. Then we have integrated collaboration servers, a tool that allows teams to collaborate throughout the whole Azure DevOps feature set, including team dashboards, project wiki, discussion within work item forms, and many others. Then we have support for exploratory testing. Manual exploratory and continuous testing are made easier with Azure DevOps, which include workflow customization, end-to-end traceability, criteria-based selection, and real-time visualization that show the test activities. And at last comes continuous integration and deployment. Many developers use CI/CD, and Azure DevOps makes it so easy to do so. Developers may automate various design activities with Azure pipelines, including defining and building association steps, writing test instructions, and managing simultaneous releases. Well, this brings us to Azure DevOps Services. You get an integrated set of services and tools with Azure DevOps to manage your software project, from planning to development to testing and deployment. A client or server model is used to deliver these services. Many of them are offered via a user-friendly web interface that works with all major browsers. So source control, build pipelines, and work tracking are just a few of the services that may be managed through a client. You can see the left pane is where you access Azure DevOps Services as demonstrated in the figure below. So now that we have covered Azure DevOps Services, let's move on to Azure DevOps Server. Version control, reporting, requirements, management, project management, automated builds, testing, and release management are all capabilities of Azure DevOps Server, a Microsoft product. It provides DevOps features and spans the complete application cycle. So now that we know what Azure DevOps Services and Azure DevOps Server are, so let's have a crisp comparison between them to know how exactly they differ from each other. Despite the fact that Azure DevOps Service is a hosted version of Azure DevOps Server. There are several features that differ. Some functions of Azure DevOps Server aren't available in Azure DevOps Services. So when deciding which platform to use or considering a transition from on-premises to the cloud, keep the following points in mind: scope and scale data, authentication, users and groups, and manage user access. So first is scope and scale data. Azure DevOps Services and Azure DevOps Server are slightly different. Organizations and projects are currently the only alternatives for scoping and scaling data. Azure DevOps Services organization get their own URLs and always have exactly one project collection, whereas deployment, project collection, and projects are the three methods for scoping and scaling data in Azure DevOps Server. Then we have authentication. To connect to Azure DevOps Services using the public internet, depending on your organization's arrangement, you can use Microsoft account credentials or Azure AD credentials to log in. You can also configure Azure AD to require multi-factor authentication, IP address restrictions, and other security features. But you connect to an intranet serving using Azure DevOps Server. Windows authentication and Active Directory domain credentials are used to log in. So this method is completely open and you will never be asked to sign in. Next we have users and groups. You may use a similar technique to grant access to groups of users in Azure DevOps Services. Azure AD groups can be added to Azure DevOps Services group. So you must add users one at a time if you utilize Microsoft account instead of Azure AD. On the other hand, by adding Active Directory groups to multiple Azure DevOps groups, you may grant user access to deployments in Azure DevOps Server. The membership of AD groups are kept in sync, so users gain and lose access to Azure DevOps Server as they are added and withdrawn in AD. And at last, there is manage user access. You manage access to features in Azure DevOps and Azure DevOps Server by assigning users to an access level. Each user in your Azure DevOps Services organization must be assigned an access level. As usual, as Visual Studio subscriber sign in, Azure DevOps Services verifies them. So without a Visual Studio subscription, you can give basic access to 5 users for free. Whereas all use of Azure DevOps Server is on the honor system. Specify the access levels on the administration page to set access levels for users based on their license and assign unlicensed user stakeholder access only. So now that we have covered all the important features and concepts of Azure DevOps, now let's move on to the next very important aspect of Azure DevOps, which is Azure DevOps Lab. The Azure DevOps Lab is a place where you can learn about software development and operations with Azure DevOps services. You can simplify and speed up the DevOps process. It explains how to use Azure DevOps services to automate software delivery and satisfy business requirements. So to understand it in a better way, let's have a demo of Azure DevOps Lab. So let's start with our Azure DevOps demo. So first, what we need to do is navigate to this website, azure.microsoft.in, or we can directly log in through dev.azure.com also. So first what we need to do is sign into a Microsoft Azure account. So after signing in, you'll be led to this page that you just need to click on continue. And here what you need to do is create an organization under which you're gonna create your projects, multiple projects, and you're gonna attach your team members to it or group members to it whom you want to give the access to your projects. So what is the difference between organization and project is, if you have given anybody access to your organization or somebody is a part of your organization, then that particular individual will have access to all of your projects. But if you have given somebody only access to your project, then he'll be only restricted to that particular project. He won't be able to access any other project that is present under that particular organization that you both are part of. So basically, organization is something that is used to connect to groups of a related project or somebody who is already a part of a particular organization. So here we will give it a name. So I am giving simply demo as the organization name. And here you can see that the projects under this organization will be hosted under the South India region, and you need to enter the captcha and click on continue. Just a second. So now you can see it is saying that it is taking you to an organization. Okay, so we already have an organization of the same name, so let's just change it to something else. Let's give it simply demo org. So here you can see it is saying that it's taking to your Azure DevOps organization where you'll be creating your projects. So now you can see your organization name here, and here you just need to create a project name. So I'm giving it simply demo project. Now below you can see visibility. We can opt either public or private. So what is public or private? So basically, if you keep the visibility of the project public, then once you copy this URL, so as I was saying, once you copy this URL into some other browser or incognito mode, you will be able to have the access to the project. But if you keep its visibility private, then only the people who have real access to your organization or to your project will be able to access that project or will be able to see that project or work on it. As you can see, public projects are disabled for our organization, so we can't select public. So we'll go for private and click on create project. Now here you can see the home page of your organization where you have this project, and here you can access the statistics of project, how it is performing, how much time you have contributed to it, or what all services you have added to your project. And down below you will be able to see that there is just one member, which is the root user of this project, and once you start adding more members to your project, it will their details will be added to this particular block. So now here you can see these are the services, boards, repos, pipelines, test runs, and artifacts services that is provided to you to add to your project. So now let's have a look at them one by one. So first one is boards. As we click on boards, you can see multiple options, your work items, boards, backlogs, sprints, queries, delivery plans. Here you can see it is all empty as we haven't added any service or we haven't worked on a project yet. So let's just click on new work item. So here you can see one is epic, issue, and task. So epic is an option that is you can see a pro option for work items. So basically epic represents business initiative to be accomplished, and it is basically available for basic, agile, scrum, and CMMI process templates. So what it exactly does is increases customer engagement, that whatever your project is, if it's the engagement of your project, that how it's performing and how it is performing towards the people whom you have given access to the project. Also helps to create new architecture to improve the performance of your project, and it also supports mobile applications. So basically when you're deploying any mobile application in your project or creating a mobile application as a project. So it will be able to support that as well. Let's click on Epic. So here you can see you need to enter a title for your Epic option. So here you need to add the title of your Epic, like for say we are creating a healthcare or an e-commerce application. So obviously it will be segmented into different parts. Like you'll be having search options or support options or home page. So we just need to give it a name. And here you can see its state is to do. For now we just have to do because we haven't actually created anything in our project and we haven't given any input. So it's in to-do list, and once we start working on it, we can change the state. It can be in progress or completing. So there are multiple states for your Epic. And here you can see the area is simply demo project. That means that we want to assign this search new Epic into this project. And we can also click description over here, that what exactly our new Epic is about. Like for search options, we need to specify or give a description that this is for searching options related to our application. Like for healthcare, one can type medicines or doctors or slots. So that is thing that we can add in our description, that it will help the user to understand what this feature is about. So this was Epic, and once done we can click on save. So here you can see other stuffs also, like priority. So we can select priority according to our will. So here by default it is priority 2. So priority basically is which function will come first. And here you can mention start date, target date. So once it's done, you can click on save. Now let's move to the next one. Second, what we have is issue. So basically issues are for you to track your work, and epics are used to track the group work and the large scenarios. But this is track like we saw the project statistics, so it will help you to understand the individual progress. So basically issues are raised when you find any obstacle in your progress or in your work. So it can be compared to impediments also. So when you're working with Agile, you need to deal with issues. So by default we have Agile to our project assigned. So like for example, we can see that we have a meeting. So during the meeting, members report if they have encountered any bug or any impediments. So what next we have to do is we have to track them and resolve it. So these are the issues that can one can find, like possibilities. So you can assign here and give it a description again and just save it. So once a user faces these issues, we can keep a track of it, and once it is raised, we can resolve it. Coming to the next one. Next we have is task. So by the name only we can well understand what task is. So a task is a smaller item or smaller segment to track activity that contains all the information needed to accomplish a part of an issue or you can say user story requirements. So this option is available for basic, agile, scrum and CMMI process templates. So again, we can give it a name, what task we want to assign, and give it a description, and according to that we can select the priority and save it. So the task will be added to your project. We are not assigning any task right now because, as I said, we haven't added any particular project or particular details or application, or we haven't deployed any application yet in our project. So that is why we are not adding anything over here again, because first we need to understand what these services are and what these services are used for. Next we have backlogs. So backlogs helps you to understand the flow of your project. Like today you have contributed 10% of your time, and you have completed the 10% of the work, or you have worked on certain segments of the project, like for say you have worked in the support area. So it helps you to understand and keep a track of the flow of your project, how it is performing and how it is developing and how it is built every day. Next we have is sprints. So sprints are basically a time-boxed intervals that supports your team's ability to work using the agile processes and tools. So what you can do is, whether you're having, let's say you're having a healthcare application, so you just need to have a segment of it and drop it over here. So what it will do is it will get the attention of all the team members. So basically what it does, it makes your project more manageable. It increases the quality of your project and also makes it work even more faster and more frequently once you add the segment to the sprint. So you can say it in one way, it gets the priority and people need to work on it, and it gives your project more flexibility to adapt to change. Now sometimes what happens is many associate Scrum sprints with agile software development. So sometimes agile are often thought to be the same thing. Coming to the next one, we have queries. So the query page basically remembers the view you have last navigated, and when you log in again or when you come back again to the same portal, it returns you to that very particular view only. So you can say that it runs with Azure DevOps command line interface, and all the open like all the pages like you have gone through, you can keep a track of it over here. You just need to click over here all, and you can just see all the queries you have defined in all this while, and also you can share the queries with the team members, so they can also know that where you have been working lately, or which segment you have been working on, or what was the last navigation which you have been going through in this whole project. So it can help you manage your project in a more efficient way and keep a track of how and what all segments you have been working on and what all segments you need to work on in your project. Coming to the next one, we have delivery plans. So here you can see we haven't created any plan yet. So basically delivery plans are a calendar view of multiple teams or team backlogs or individual backlogs from different projects. So basically it replaces the delivery plans marketplace extension, and it is only available for Azure DevOps services. So here you can say it's a summary or time summary of all the projects you have been working on in a particular organization. So now that we have covered both, let's move to the next one, which is repos. So with the name itself, we can well understand that repo stands for repositories. So basically it is a set of repositories that allows you to control and manage your project code. Like for say you're deploying a healthcare application, so these repos options help you create repositories and manage your code of that particular application in a more efficient way. So what you can do is you can connect project solutions by using the repos link. As you can see here, it is shown. So let's look into its option one by one. First we have files. So in files, your project solution will be available in this section. So repositories can create, manage and import those solutions. Okay, so you just need to upload your solutions of your code or your project here, and it will just create repositories for it, and it will help you manage those solutions in a better way. And you can see these clone to your computer, push an existing repository from command line, and import a repositories if you want to import any solution. Like here you can just click on import and add the solution to a repository. So this is what files do. Basically you can see it's like a physical folder itself where you have all your mini files or repositories or solutions, you can say, of data. So basically it functions like a physical folder itself. So it helps you keep a track of your codes and everything. Next comes is commits. So in commit section, we can manage commit history for your repositories that you have created in files. So it just commits those repositories with author details from branches. Like for say we have a team, one from support branch and one from management branch. So whoever creates that repositories and adds the solution, it commits that repositories under that particular member of the team with the branch name. Then comes pushes. So push histories are available in this section from each pull request done by the developers. Developers, for say, the team members who have been working on this particular project and creating repositories and solutions. So what is pull request? So pull request or PRs are a way to change or review or merge code in our repositories. So basically team uses these PRs to review code and give feedbacks or changes, whether like for say you are deploying a code or a solution. So one can review them, what all changes needs to be made or what all upgradation needs to be made, or whether the code is already fine or not. So basically teams use these PRs to review the solutions and codes stored in these repositories, or you can merge multiple solutions or multiple codes into the main branch. So basically reviewers can step through the proposed changes and leave those comments and vote to approve or reject that particular code, or you can say to upgrade or what all changes we want to make it. They vote for it, that whether that needs to be made to that particular solution or not. So these are the PRs. Next, we have branches. So we can manage multiple branching information in this particular section. You can create or release branches from master to dev. Okay, so all users can actually can actually create or release branches from branching information available in this particular section. Next come tags. So tags are used to point out specific commits, like giving message tags and data information to branches. You can create your naming conventions to branches by using commit tags. And the next one is pull request, which we have already discussed. The PRs that are basically used in pushes. So now we have completed repos also. So let's move on to the next one, which is pipelines. So here you can see that we don't have any pipeline created for us yet. So let's have a look at its provided options one by one. So the first one is environments. So basically it is a collection of resources where you actually deploy your application that you're working on. So you can say it contains one or more virtual machines, containers, web apps, etc. Whatever resources you have actually used for deploying your application, or what are services you have used for creating the environment for the deployment of your application. For say we need to deploy our application and it needs an Windows Java environment. So whatever resources you need to create that environment, that will be added to this environment list. It will be listed over this section. Next we have releases option. So basically this pipeline stores the data of your pipelines or stages or tasks and deployments in Azure pipelines, that deployments you have done so far in your applications, for your applications actually. So you can say that it helps your team continuously deliver software to your customers at a faster pace with a very minimum, you can say, lower risk. So you can fully automate the testing and the delivery of your software or applications on multiple stages. Or you can also set up an automated process with approvals and on-demand deployments. Then comes library. So again you can see the page is blank. From the name itself you can scrutinize that it will be a collection of assets from Azure DevOps projects. So basically it is a collection of build and release assets of a particular project. So assets defined in a library can be used in multiple builds and multiple releases pipelines of the project. Okay, so all assets that are defined in a library share a common security model. So you can control who can define new items in a library and who can use an existing item that you have already added in this library. So roles are defined for library items. Per se, you have added a particular asset or particular item to this library segment, and you can assign a particular member who will be working on this item. Okay, so roles are defined here for these, and these governs the operation you can perform on those items. That person will be keeping track of whatever changes have been made or whatever upgradation has been made to the particular item that has been added to this segment, library segment. So then comes task groups. So task groups are a way to standardize and centrally manage deployment steps for all applications in your projects. So when you include a task group in your definition and then make a change centrally to the task group, the change is automatically reflected in all the definitions. So we can conclude with this that a task group allows you to encapsulate a sequence of tasks already defined in, you can say, build or a release pipelines or into a single task group. So it just encapsulates all those sequence of tasks. So you can choose to extract the parameters from those encapsulated tasks as configured variables and abstract the rest of the task information. So what happens is the new task group is automatically added to the task catalog and it is ready to be added to other release and build pipelines. So task groups are stored at the project level and are not accessible outside the project group. So the task groups will be only limited to the members who you have assigned in this project, and it won't be accessible to the other people or other team members from different projects, even though they are the member of the same organization. So you can say it's more of a private segment. Now that we have covered task groups, next we have deployment groups. So deployment groups are only available with classic release pipelines, and it is totally different from the deployment jobs. It is basically a collection of deployment related steps defined in a YAML file to accomplish a specific task. So in a nutshell, it is a logical set of deployment target machines that have agents installed on each one. The deployment groups represent the physical environment, for example, testing or development or production environment. So a development group is just another grouping of agents, much like an agent pool, you can say. So what you can do with this is you can specify the security context and runtime targets for the agents, or you can let yourself view live logs for each server as a deployment take place. Or you can also enable you to use machine tags to limit deployment to a specific set of servers. So this was about deployment groups. Now that we have covered one more service, let's move on to the next one, that is test plans. So test plans, the first one we have is progress report. So you can analyze with this only. The progress report will be the progress of the project you have been working on, or the deployments you have been doing, or the tasks you have been performing. So basically it lets you analyze and view data for more than one or an individual test plans in a particular project. So data for test plans can be migrated from an on-premises Azure DevOps server that won't show up in this report. Okay. So basically this section lets you drill down by each test plans and give you summary of each test plan in it. So this section also lets you to navigate to a test plan or suite of choice by double clicking on it. Okay. So this was the progress report. Next we have runs. So basically it represents the execution of pipelines. So during a run, the pipeline is processed and agents process one or more jobs. So when you run a pipeline, many things happen under the cover. While you often won't need to know about them, occasionally it's useful to have the bigger picture, right? So Azure pipelines will get processed under this test runs segment. So you'll be able to see what all performance is happening over here. Like while you're running a pipeline, you can see the running state, the date you have started that. or what all that running pipeline includes, like jobs, steps, and tasks. So runs power both continuous integration and continuous delivery pipelines. Next we have load test. So basically Azure load testing is a fully managed Azure service that enables developers and testers to generate high-scale load with custom Apache JMeter scripts and gain actionable insights to catch and fix performance bottlenecks at scale. So basically, application performance and resiliency are more important than ever before. So how you can run an Azure DevOps test? So first you need to click on it and select a test suite that contains all the automated tests, and you can just choose the run test option. And it will start processing it. So this service basically simulates traffic for your application, you can say, regardless of on which platform or where it is actually hosted. So now that we have covered test plans as well, let's move on to the next one, that is artifacts. So this is the last service that is provided to your project by Azure DevOps. So artifacts is a byproduct produced during the software development process. So it mainly consists of the project source code, dependency, or binaries or resources that could be represented in different layout depending on the particular technology. So it's like an extension that makes it easier to discover, install, or publish and Maven packages in Azure DevOps. It's basically deeply integrated with other hubs like Build, so that package management can become a seamless part for your existing workflows. So what is exactly it is used for? So it can be used for both public and private organization with teams of any size. It basically manages your NPM or NuGet packages via feeds, and it allows you to create and share your Maven. So it's a package management solution integrated with your Azure DevOps. So this was all about the services that is provided to your projects. So now that you know what all services do for your project and what are their benefits and how they function, now you can actually plan your project and start creating and working on it and start deploying with the users and what all services you want for your particular project. So what you can do is click here on project setting. Just a second. Yeah, you can just click on project setting. So now what you can do is you can add in description that what your actual project is about. So for say, like I said, if you're creating in a healthcare application, so you can just give it a description that it is for healthcare related issues, queries, and helps needed, and like you're tying that particular application with different hospitals or healthcare organizations. So you can actually add those information in this description. And the process, which basically it is basic or private one, but you do get a range of process for your project when it depending on the visibility of it, like for Agile or Scrum, you can say. So now here you can see that only my ID is attached to it, as I'm the only member here and I'm the administrator. So you can add members here, and scrolling down, you can, now that you know what all services provide you or what they provide to your project, so depending on the need of your project, you can just select the services you want to assign to your particular project. Like, for say, if I don't want boards assigned to it, or you can say if I don't want the services provided by the boards. I can just click on it and select remove boards, and I just need to refresh it. So yeah, here you can see I have overview, repos, pipelines, artifacts, but I don't have test plans and boards. As you can see, test plan is basically all the collection of whatever you're managing, which is indirectly assigned to the boards. So as you remove the boards, the test plans also get removed. Okay, and once like this, you can just select what all services you want specifically, and if you want to delete your project, you can just go ahead and delete it. So this was all about the Azure DevOps services and the Azure DevOps Virtual Studio, we can say, and how the demonstration of how a project actually functions in this Virtual Studio.
Hey guys, I'm Rahul and I'll be representing Amazon Web Services.
I'm Chinmayi and I'll be representing Microsoft Azure.
And I'm Shruti and I'll be representing Google Cloud Platform. So welcome to this video on AWS versus Azure versus GCP.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage, and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning, and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro-instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto-scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google Query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM Image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with EC2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software as a service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides DynamoDB, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL It natively supports NoSQL, created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS, in networking and content delivery, we have AWS Route 53 and AWS CloudFront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStart and AWS CodeBuild. For security, we have IAM and Key Management Service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and Express Route. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stack Driver and GCP Monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. Speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline, and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget friendly when it comes to downloading data from Google Cloud Storage.
Microsoft offers 3 certification paths for a variety of technical jobs. To gain certification, you must complete a series of exams. And the first one is Fundamentals Certification. These certifications are suitable for those who are just getting started in technology or considering a career shift. Second is Role-Based Certification. To begin acquiring valuable job role abilities, choose a role-based certification. Third is Additional Certification. Examining Microsoft Office technical qualifications as well as Specialist and Microsoft Certified Educator certifications. Now in each category, we have sorted the certifications for your better understanding. In the first category, Fundamental Certification, are Microsoft Certified Azure Fundamentals, Microsoft 365 Certified Fundamentals, and Microsoft Certified Power Platform Fundamentals. In the second category, role-based certifications are Microsoft 365 Certified Security Administrator Associate, Microsoft Certified Azure Developer Associate, and Microsoft Certified Dynamics 365 Sales Functional Consultant Associate. And in the third category, additional certifications are Microsoft Certified Azure for SAP Workload Specialty, Microsoft Certified Educator, and Microsoft Office Specialist, Microsoft Word Expert. So let's start with the first one, Microsoft Certified Azure Fundamentals. The Azure Fundamentals certification allows you to demonstrate that you understand cloud concepts, Azure services, Azure workloads, Azure security and privacy, and Azure pricing and support. Candidates should have basic understanding of technical fundamentals such as networking, storage, computation, application support, and application development. Candidates for the Azure Fundamentals certification should have a solid understanding of cloud services and how Microsoft Azure deliver them. This certification is for applicants who are new to Azure or who are just starting to work with cloud-based solutions and services. Moving ahead, let's look into its skills requirement. Describe cloud concepts, describe core Azure services, describe core solutions and management tools on Azure, describe general security and network security features, describe identity governance, privacy, and compliance features, and describe Azure cost management and service level agreements. This certification is suitable for job roles like administrator, business user, developer, student, technology manager, and its exam code is AZ900. Price of this examination is $99 USD and the renewal time is 2 years. Coming to the next one is the Microsoft 365 Certified Fundamentals Certification. It verifies that you are familiar with Microsoft 365 feature and benefits, as well as the advantages of using cloud services, the software as a service, cloud model, and the Microsoft 365 cloud service. These are the skills required to earn this certification. Describe cloud concepts, describe core Microsoft 365 services and concepts, explain security, compliance, privacy, and trust in Microsoft 365, and describe Microsoft 365 pricing and support. This certification is apt for job roles like business user and administrator, and the exam code for this examination is MS900. The examination fee is 99 USD and the renewal time is 2 years. Next is Microsoft Certified Power Platform Fundamentals. If you're a student, a business user, or a new technical professional using your Microsoft Power Platform skills to better your team's efficiency, this certification can help you advance your career. To prepare for it, you only need a basic understanding of computer technology, data analytics, cloud computing, and the internet. Consider a fundamental certification the initial step towards expanding your skill set and moving on to more advanced certifications like Microsoft Power Platform Functional Consultant. And the skill set required for this certification are describe the business value of Power Platform, identify the core components of Power Platform, demonstrate the capabilities of Power Platform, describe the capabilities of Power Apps, demonstrate the capabilities of Power Automate, demonstrate the business value of Power Virtual Agents. This certification is perfect for job roles like business user, functional consultant, student, and its exam code is PL900. The examination fee for this exam is 99 USD and its renewal time is 2 years. Now let's dive into the second category, which was role-based certification. The first certification exam in this category is Microsoft 365 Certified Security Administrator Associate. Microsoft 365 Security Administrators protect Microsoft 365 Enterprise and hybrid environments by proactively securing them and implementing and managing security and compliance solutions, responding to threats, and enforcing data governance policy. This exam assesses your ability to use Microsoft 365 to implement and manage identity and access, threat protection, information security, and governance and compliance features. The skills required for this certification are implement and manage identity and access, implement and manage threat protection, implement and manage information protection, manage governance and compliance features in Microsoft 365. Now, this certification is perfect for the administrator role and its exam code is MS500. Its examination fee is 165 USD and its renewal time is again 2 years. Then comes Microsoft Certified Azure Developer Associate. Candidates for the Azure Developer Associate certification should have experience designing, developing, testing, and supporting Microsoft Azure cloud applications and services, participating in all aspects of cloud development from requirements, definition, and design to development, deployment, and maintenance, as well as performance tuning and monitoring is part of its role responsibilities. Now, the skill set essential for this certification are develop Azure Compute Solutions, develop for Azure Storage, implement Azure Security, monitor, troubleshoot, and optimize Azure solutions, connect to and consume Azure services and third-party services. Now, this certification is for a job role like developer and its exam code is AZ204. Its examination fee is 165 USD with the renewal time of 2 years. Moving on, next is Microsoft Certified Dynamics 365 Sales Functional Consultant Associate. This certification could help you advance in your career if you're a functional consultant, a Microsoft Dynamics 365 sales professional, or a developer wishing to improve your consulting skills. It enables you to better pitch yourself for projects and demonstrates to your company how Dynamics 365 sales can be used to empower salespeople. You have expertise with Microsoft Power Platform and are familiar with Dynamics 365 model-driven apps and data modeling techniques as a candidate for this certification. For this certification, skills required are perform configuration, manage core sales tables, configure additional tools and services, configure Microsoft Dataverse, create apps by using Microsoft Power Apps, create and manage Microsoft Power Automate, implement Microsoft Power Virtual Agents chatbots, integrate Microsoft Power Apps with other apps and services, and manage solutions. Now, this certification is suitable for the functional consultant profile, and the exam code for this exam are PL200 and MB210. The examination fee for this exam is 165 USD and the renewal time is 2 years. Now comes the third category, additional certification. And the first certification exam in this category is Microsoft Certified Azure for SAP Workloads Specialty. Architects or engineers with substantial experience and knowledge of the SAP system landscape and industry standards that are particular to the initial migration or integration as well as the long-term operation of an SAP solution on Microsoft Azure should apply for this certification, making recommendations on services and modifying resources as needed for optimal resiliency, performance, scale, provision, size, and monitoring are among the responsibilities of an architect or engineer for Azure for SAP workloads. Skills required for this certification are migrate SAP workloads to Azure, design and implement an infrastructure to support SAP workloads, design and implement high availability and disaster recovery, maintain SAP workloads on Azure. Now, this certification is perfect for job roles like administrator, solution architect, and its exam code is AZ120. Its exam fee is 165 USD with the renewal time of 2 years. Then comes Microsoft Certified Educator. The Microsoft Certified Educator (MCE) credential verifies that teachers possesses the global educator technology literacy competencies required to provide students with a rich, personalized learning experience. Educators in training, instructors at teachers' education colleges, and in-service educators all benefit from MCE certification. So these are the skills required: facilitate student collaboration, skilled communication, self-regulation, real-world problem-solving and innovation, facilitate student use of information and communication tools, and use ICT to be an effective educator. Now, this certification is suitable for developer and educator profiles, and its exam code is 62193. Its examination fee is 127 USD, and its renewal time is 2 years. Now comes the last but not the least one in this category, and it is Microsoft Office Specialist Microsoft Word Expert. Earn the Microsoft Office Specialist Word Expert certification to show that you have the skills needed to get the most out of Word. This credential demonstrates proficiency in the creation and management of professional papers for a variety of purposes and scenarios. The skills essential to gain this certification are manage document options and settings, use of advanced editing and formatting features, creating a custom document elements, and use advanced Word features. Now, this certification is suitable for job profiles like business users, and its exam code is MO101. The exam fee for this certification is 100 USD, and its renewal time is 2 years. So this was all about Azure certification part. Apart from this, not only will you need to learn how to design, manage, and protect Azure cloud systems in order to become certified and land a job, but you'll also need real hands-on experience.
Cloud computing refers to services like storage, databases, software, analytics, machine learning, artificial intelligence, and so much more, all of which made accessible via the internet. The cloud tech services market is expected to grow 17.3% in the span of 2018 to 19, which means there's a growth from $175.8 billion to a whopping $206 billion in 2019. And as of 2020, it's expected that 90% of all organizations in the world would be using cloud services. Not to mention, several organizations around the world suggest that using cloud computing services has enabled their employees to experiment a lot more with technologies like machine learning and artificial intelligence. So here's what we'll be going through today. Firstly, we'll be talking about who is a cloud computing engineer, the steps you need to take to become a cloud computing engineer, and the cloud computing engineer salaries. So first off, who is a cloud computing engineer? Now, a cloud computing engineer is an IT professional who takes care of all the technical aspects of cloud computing. Now, be it design, planning, maintenance, and support. Now, a cloud computing engineer can take up a number of different career paths. This could be that of a cloud developer, security engineer, a full stack developer, SysOps administrator, solutions architect, cloud architect, and so much more. Now, let's have a look at some of the major cloud computing roles. First off, we have solutions architect. Now, these are individuals who are responsible for analyzing the technical environment in which they are going to produce the solutions, the requirements, and the specifications. Secondly, they are required to select an appropriate technology that satisfies said requirements. They need to estimate and manage the usage and the operational costs of the solutions they provide, and they need to support project management as well as solution development. Next, we have SysOps administrators. They are involved in deploying, managing, and operating highly scalable and fault-tolerant systems. They need to select an appropriate service based on compute, security, or data requirements. They need to estimate and manage usage and operational costs, and they need to be able to migrate on-premises workloads onto an appropriate cloud computing platform. So among both of these roles, there are certain requirements that are remaining constant. Now let's have a look at the steps you need to take to become a cloud computing engineer. Your first step is to gain proficiency in a cloud computing platform. Now the first step is to become proficient in at least one of the three major cloud computing platforms, be it AWS, Azure, or the Google Cloud Platform. Now, there are a huge number of resources that you can find on the internet. It could be YouTube videos, articles, virtual or physical classrooms, and so much more. Now, after you're done learning, you can get certified by Microsoft Azure, AWS, or the Google Cloud Platform. Now, for AWS, you have a number of different certifications, which can be divided into three categories, which are the foundational, which is just the basics, the associate level certifications, the professional level certifications, and the specialty certifications. Similarly, with Microsoft Azure, you have certifications that enable you to become an Azure Developer Associate, an Azure Administrator Associate, an Azure Architect Professional, and a DevOps Engineer. Now, most cloud computing platforms have a free tier that you can take advantage of. These provide a number of free services for a period of time, some of which are free forever. So you can use these platforms to your advantage and do as much practice as you can on them. Now, if you want to learn more about cloud computing, you can also check out Simplilearn's YouTube channel. Then you can go on to the playlist section right here, and you can find comprehensive videos on a number of different cloud computing platforms, AWS and Microsoft Azure. Our AWS tutorial videos talk about what exactly is AWS, how you can become an AWS Solutions Architect, Amazon EC2, S3, some of the other services, and so much more. We also have detailed tutorials on Azure, which talks about what exactly is Azure, the certifications provided by Azure, some of the services like machine learning, Azure Active Directory, and so much more. And now we're at step 2, being experienced in at least one programming language. Unlike general purpose programming languages like C, C++, C#, and so on, cloud computing requires ones that are a lot more data oriented. Now, some of the major programming languages that are used in cloud computing are Go, Python, Clojure, and Java. Now, as I said before, there is a wealth of resources that you can learn from. There are free websites that you can practice your code on, like Quick Code, Code Academy, and several others. There's also resources like YouTube videos, as well as there's the option of online or offline classes. Now we're at step 3, specialization. You'll also need to be well versed with a number of key concepts. These are storage and networking. Now, with storage, you need to know how data can be stored and where it can be accessed from. You need to know how it can be accessed from multiple different resources. You'll also need to have some experience with the services provided by Azure and AWS, like the Amazon S3 in AWS and the appropriately named Azure Storage from Microsoft Azure. With networking, you need to have a strong understanding of the networking fundamentals as well as virtual networks. Next up, we have virtualization and operating systems. With virtualization, you need to know how virtual networks, which is just a combination of different virtual machines, can be used to emulate different components in a particular system. With operating systems, you need to have a very strong understanding of operating systems like Windows and Linux. Next up, we have security and disaster recovery. Now, you need to understand how data, application, as well as infrastructure can be protected from malicious attacks. With disaster recovery, you need to be prepared for any unexpected circumstance by making sure your systems are always safe and are regularly backed up to prevent any sort of loss of data. Then we have web services and DevOps. Now, you need to have a strong understanding of APIs or application program interfaces and web services. Some amount of experience with web design also can be of great help. With DevOps, you need to have a strong understanding of how cloud computing is able to provide a centralized platform on which you can perform testing, deployment, and production for DevOps automation. Moreover, with DevOps, you understand the synergy that the operations as well as the development teams have with each other and for the success of any project. And finally, you're a cloud computing engineer. Now, let's have a look at the salaries of cloud computing engineers. In the United States, cloud computing engineers earn around $116,000 per annum. In India, a cloud computing engineer is paid approximately 6,66,000 rupees per annum. Now, how can Simplilearn help you become a cloud computing engineer? So let's head on to Simplilearn's website. Here we have the Cloud Architect Master's Program. Now, this deals with a number of different courses, all of which that can help you get started in your journey to becoming a cloud computing engineer. This Master's Program covers a number of different courses like AWS Technical Essentials, Microsoft Azure Fundamentals, AWS Developer Associate, and so much more. It provides you 40 plus in-demand skills and 25 plus services, provides you a master's certification. It has 16 plus real-life projects and helps you get a salary that ranges between between 15 to 25 lakh rupees per annum. It also covers a variety of tools like Amazon EC2, Azure Data Factory, virtual machines, and so much more. So why don't you head on to simplilearn.com and get started on your journey to getting certified and getting ahead.
And with that, we have come to the end of this video on Azure tutorial for beginners. I hope you found it useful and entertaining. Please ask any questions about the topics covered in this video in the comment box below. Our experts will assist you in addressing your problems. Thank you so much for being here. Stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.